Hello guys, welcome to my channel Aero Civil. In this lecture series we are talking about we are solving basically two questions regularly for GATE 2022, and we are solving some expected question which can be come in GATE 2022 examination. And last 2 days I was not able to upload this daily lecture series of question answer solving. I will make up in upcoming lectures. Okay, so before starting the lecture I will request you, those who haven't subscribed or like my channel, I will request them to please subscribe this channel and press the bell icon. When I will upload new video or new content, you will get notification at first. Okay, so let us start our today's question. So the first question is, a rectangular reinforced concrete beams of 250 mm wide and 400 mm effective depth is to analyzed based on modified maximum strain in concrete as 0.003. Okay, so the maximum strain in concrete is 0.003 and the dimension of the rectangular RC beam is given, and strain in steel as Fy by 1.15 ES plus 0.0025. The beam is reinforced with 3 bars of 16 mm dia with an effective cover of 30 mm. The material used are M20 concrete and HYSD grade Fe 415 bars. Okay, so total dimensions and the information of the beam is given. Okay, we have to find the balanced neutral axis. Okay, we have to find what is the balanced neutral axis. Now at first let us draw the diagram. Okay, let us draw the beam diagram. Okay, so this is the beam. Now we will draw the strain diagram. So the strain in concrete, it is given 0.003 and strain in steel is given this. Okay, so okay, so this is the beam with 3 reinforced bar, and this is the strain diagram. At the top portion it is showing the concrete zone where the strain is 0.003. At the bottom portion is steel zone, the strain is this. Okay, now what we have to find? We have to find the balanced neutral axis. This depth is small d. Okay, and this depth is xu. Okay, this depth is xu max. Now what we can write from the similar triangle, if we take this triangle and this triangle, okay, there are two triangle. Okay, if we take this triangle and this triangle, from the triangle similar triangle rule, we can write in this way that xu max whole divided by 0.003 equals to this distance. Okay, xu max means this distance. Now from this triangle we have to write this distance. So this is coming as d minus xu max by, here we have written 0.003. Now we have to write this zone, Fy by 1.15 ES plus 0.0025. So is that clear? We have write this relationship from similar triangle. Okay, this is one triangle, this is another triangle. Okay, now what we can do? We can do xu max equal to 0.0025 0.003, if we take 0.003 here, and if we put d minus xu max here, it is coming like this. Okay, now what we have to do, we have to put all xu max in left hand side and rest of the portion in the right hand side. So what we can write, xu max, okay, if we multiply this again, it is coming like fy 1.15 es plus 0.0025, okay, and this 0.003 into d minus xu max. Okay, we have multiplied in this way. Okay, this into this into this. Now what we can write, xu max fy 1.15 es plus 0.0025, here it is coming d into 0.003 minus 0.003 into xu max. Now if we take xu max in this side, it is coming xu max, suppose we are considering this as a z into z plus 0.003 xu max 0.003 into d. Okay, z means this value. Now if we take common xu max, it is coming z plus 0.003 equal to 0.003 d. Now what we can write, if we take xu max equal to, it is coming 0.003 d. If we put z value, it is coming fy by 1.15 es plus 0.0025 plus 0.003. Okay, now we have find what is the value of, what is the formula for xu max. Now we have to put all the values. Okay, here what is the value of d is given, 400 millimeter effective depth, small d is 400 millimeter. Okay, 0.003 into 400 whole divided by, here fy is 415 1.15 es, modulus of elasticity of steel, we all know it is 2 into 10 to the power 5 MPa. Okay, plus 0.0025 0.003. now if we solve this, it is coming as xu max equal to 164.285 millimeter or 165 millimeter. Okay, this is the actual, we are approximately writing this. Okay, just ignore this, it is coming 164.285. now if we see the options, what is the nearest option, 160.41 is the nearest option. Okay, so 164.285 is coming, we can choose the option is 160.41. Okay, so this is the solution for first problem. Now move on to the next question. Okay, now the next question, it is asked the difference in above neutral axis compared to maximum neutral axis calculated as per IS 456 is. Now we have find xu max equals to 160.41. Okay, we are considering this answer because this is in option. Okay, now they have asked us to calculate the difference between maximum neutral axis and neutral axis as per IS 456. Okay, now as per IS 456, we know for FE 415 the formula for xu max for balance section, it is coming 0.48 D. Okay, we know that for Fe415 it is coming like 0.48 D. Okay, this is the formula. Now if we find as per code the neutral axis value is 0.48 into small d, here d is 400, so it is coming 192 millimeter. Okay, this is using codal provision. Okay, now what we have calculated, we have calculated XUmax calculation. Using calculation we have found that XUmax value is 160.41. now we have to find the difference. Okay, so the difference is 192 minus 160.41 in millimeter, it is coming 31.59 millimeter. Okay, so the option for this is 31.59 millimeter. Okay, that's all for today, and thank you for watching this video, and please subscribe, and very soon I am going to upload the next soil mechanics lecture, and for fluid mechanics I will upload a marathon class. That means in one lecture I will complete the total fluid mechanics. Okay, in one lecture I will complete the total fluid mechanics. In this way I will complete each and every subject. Okay, so thank you, subscribe this channel.